Ladies and gentlemen, welcome back to Let's Delve. Now lately I've been playing a ton of Littlewood. It's a charming little Animal Crossing style game that can be played at your own pace. It's been nice to take a break from the soul-crushingly punishing games that I usually play and just live the cozy life of a retired hero looking to return to normalcy. Anyway, the movement in Littlewood is very much inspired by the old school RPGs of yesteryear. It's a movement style I've always wanted to try remaking, but never got around to. Which brings us to today's plan. We'll attempt to try recreating the old school top-down RPG movement style. Since I've never tried this before, we'll break things down and take it step by step. And hopefully by the end of things, we'll have remade something similar to or exactly like the movement from old school RPGs. Sounds like a plan, so let's get to the coding. So, old school RPG movement was grid-based, which means, yep, we're gonna need to break down our room into a grid. So while I do that, let's also break down exactly what the old school RPG movement style entails. Let's use Pokemon as an example, mostly because it's probably the one I'm most familiar with. In the old school Pokemon games, movement was confined to grids, but instead of simply teleporting the player cell by cell, there existed a smooth transition, which helped mask the grid-based nature of the overworld. This is the effect we're after, one I'm not exactly confident I'll be able to replicate, so we're gonna take things slow. 3 variables would be added to the player object: player angle, walk speed, and the walk cooldown timer. Then to start, I wanted to simply move the player cell by cell. So using the same loop code we've used in the 2D Minecraft project, I had the movement direction set based on key presses and a loop. The key press would also set the walk cooldown for half a second. This thankfully ended up working just fine, so now it was time to try adding a transition. First, a walking boolean was added, and while walking is set to true, the player would move in the direction based on the angle variable. For now, the movement would be 1 pixel per frame, and since we're working with 16 by 16 cells, the walk cooldown was changed to 16 frames to match the walk speed. Then once the walk cooldown reaches 0, it would reset the walking boolean to false, allowing the player to initiate the walking code again. This almost worked. The player would indeed walk based on our values, but it would only occur when the key was held down, thus breaking the whole, grid-based thing. So returning to the code, I had the controls only work when the player's walking state is false. This surprisingly worked perfectly. The player shifted cell by cell, frame by frame, and remained on the grid throughout. Movement could only be initiated once the player reaches their destination, and holding down the movement key was just as seamless as in the old school Pokemon games. However, as great as this was, I wanted to make things more dynamic. So back to the code, I swapped out the static walk speed and timer for some math based on the walk speed variable. And while it may be hard to tell here, my math was thankfully accurate, and thus the player's walk behavior was now based on their walk speed value. So with movement working, I wanted to add something I feel like was almost exclusively a Pokemon thing, and that's being able to turn in place. Back in the player code, I added a check to the walk controls. If the next direction matched the way the player was already facing, we'd initiate the walking code like normal. However, if the player has decided to move in a new direction, instead of initiating the walk code, we would just update the player's direction. Now, this may be hard to see right now, but trust me, it's working. And we'll prove that it's working in a bit, but first, it was time for collisions. Back in the player's walk code, a grid check was made, and much like the 2D Minecraft code, if the destination cell is not marked as a wall, the player is free to move in that direction. Then to test this, I had the grid randomly place some walls, and added the ability to remove walls for testing purposes. This indeed ended up working flawlessly, with players only being able to traverse open spaces. Any cells marked as walls, drawn as gray blocks, are not passable. So with that working, it was time to return to the visual aspect to load in some sprites. An array was created which would hold the sprite data for each of the 4 cardinal directions. The sprite index would then be determined based on the player's angle variable, and if the walking state is true, the animation plays. Otherwise, the animation resets to the first frame and the image speed is set to 0. Which ended up looking a little weird when combined with the movement speed, but it worked. Now, admittedly, I expected this to take me an hour or so to figure out, but surprisingly, it only took me less than 30 minutes. So with the extra time, I decided to add some Littlewood flair to the mix. In the player control, a spacebar check was made. This would place a dirt tile down wherever the player is standing. Now granted, placing dirt like this isn't a Littlewood thing, but it goes to show just how much easier interactivity is with a grid-based movement system. So next, just to see what would happen, I wanted to add a run mechanic. So if the player is holding M, because my shift key is broken, the walking speed variable would be modified, thus speeding up our walking code by twice the speed. And this ended up not working out too well. My guess is the math becomes a bit more complicated, and so some extra math may be required to make sure that the grid behavior remains intact. Regardless, the ratio of things that did and did not work this session heavily favored success, so I can't be too disappointed. Again, I was extremely surprised to see how smooth this experiment went. I honestly expected a lot more complications because, you know, I'm terrible at math. But it was encouraging to manage a similar effect with little to no errors or issues. Perhaps we'll use this in future projects. Well, at the very least, this was a great learning experience. So with that brings us to the end of today's episode of Let's Delve. So leave a like if you enjoyed the episode, subscribe and turn on notifications if you haven't already, leave your thoughts on our approach to the old school RPG movement style in the comments. Thank you so much for watching, and I'll see you guys next time.